Hello everyone, welcome to Solidworks simulation channel. Today you will learn how we can apply a cyclic symmetry boundary conditions and also learn how to apply symmetric boundary conditions. And you will also calculate the radial stresses, axial stresses as well as hoop stresses in a pressure vessel. And you will also at the end will compare the results of these stresses with hand calculations. So let's start our study now. So first of all, make a sketch on the front plane with these dimensions. Here is the symmetric model of a cylinder with a diameter of 200 millimeter and overall length is 400 millimeter. And here is 200 millimeter because it is symmetric about this plane. And thickness of cylinder is 25 millimeter. So exit from sketch now and make a partial revolve at the angle of 90 degree. After that, you will add a fillet to this face in order to avoid the stress concentration at this sharp edge. So select this edge and enter the radius of fillet, that is 25 millimeter. So it's time to run or start our SolidWorks simulation study. So then go to the simulation tab and click the simulation, and from the general simulation type select the static. Here you can see that you can give a specific name to your study. We leave it default. After that, assign the material, that is alloy steel, to this cylinder. Now it's time to define three symmetric fixtures on this face, as well as on this face. Before starting study, we will make a reference axis. The reference axis is necessary to define a cyclic symmetry conditions. So select on the option, that is line or axis, then select this circular face. You can see we have a define our axis, that is axis 2, in order to define a cyclic symmetric boundary conditions. Now go to the simulations and start a new simulation and ensure that static type is selected. OK. First of all, we will assign material, that is alloy steel. After that, we will apply cyclic symmetry fixtures. Now go to the fixtures and from fixed geometry, go to the advanced options. From here, select the cyclic symmetry. Here, select the first phase, that is this one. Then second phase is this one. And for axis, select this axis. So you can see the preview of a cyclic symmetry. OK. After that, we will apply this hole. Actually, we have modeled a half cylinder or spherical. Then we will apply symmetry fixtures in order to model a complete cylinder behavior. Again, go to the advanced options and select the symmetry. Clear this one and select this face. You can see the preview. OK. So we have applied a cyclic symmetry fixtures as well as symmetry fixtures. Now apply a load of pressure 35 megapascal on inner faces, on this face, on this face, on this face. Units are megapascal and value is 35 megapascal. Ensure the direction is inward or toward the surface of cylinder. Okay. Now we will keep or leave our mesh values default. Just run your study now. Our simulation study has been completed. Here is the one measure stress values. We are concerned with the normal stress, that is the hoop stress in x direction, and the axial stress, that is the normal stress in the y direction, and the radial stress, that is the normal stress in z directions. So again go to the results, define stress plot, and from here select the x normal, units are megapascal, and change units to megapascal to floating. So in order to see the normal stress, just right click here and go to the probe and select a point on this inner line. You can see that the normal stress is 119 megapascal in extractions. That is the hoop stress. Again go to the define stress plot, and at this time you have to define the y plot megapascals and change units to megapascal, then floating. Here is the normal stress in the y directions, that is the stress plot. That is the axial stress. So go to the probe and select this line. You can see the normal stress in y direction is 46.5 megapascal. Similarly, again go to the defined stress plot, megapascal, and the normal stress in the z direction, that is the radial stress. Okay, that is the radial stress. Just use the probe and select this line. You can see the normal stress or radial stress is in compressive state, that is negative 34.7 megapascal. So in this way we calculated the axial, normal, axial, radial as well as hoop stresses in a cylinder by using symmetry fixtures as well as cyclic symmetry boundary conditions. We can recreate a mesh and go to the use the curvature based mesh and reduce the element size to 5 millimeter. Mesh is being regenerated now. Now run your study. So if we check the normal stress in x directions, use the probe again and see this one, that is 122 megapascal. That is a little bit different from the previous study where element size was about 10 millimeter. Similarly, the axial stress, use the probe, is almost same as that of previous study, that is 46.5 megapascals, and the radial stress, use the probe, that is 35 megapascal. You can see you should select on this line because this value was selected not here on this phase. You can compare the results. This is the SDC publications. You can see the hoop stress is 125, where this was the ANSYS workbench simulations, but our results are 122 megapascals, and the axial stress is almost 45 megapascal theoretically, and Solidworks simulation result is almost this one, 45.5, and the radial stress is almost same as that of this paper present. So I hope you enjoyed this simulation study. Please make a practice of this. Thank you for watching. Take care. Bye bye.